In this lecture, we will introduce the Tower of Hanoi problem, and we'll also discuss how to solve the problem using recursion.
In the 19th century, there was this game called the Tower of Hanoi, which was very popular in Europe. This game was actually based on an old legend that was concerning the construction of the Temple of Brahma. Now, according to this legend, when the universe was created, there were priests in the Temple of Brahma, and they were given 3 diamond needles. One of these needles contained 64 golden discs, and each of these discs was slightly smaller than the disc below it. So the bottom disc had the largest disc, the next one had the second largest disc, and the top disc was the smallest of them all. It was up to the priests to move all 64 discs from the first needle to the third needle, but they had to follow 3 rules. The first rule is only one disc can be moved at a time. So they couldn't just move like 3 discs all at once. They could only do one at a time. The next rule was that the removed disc must be placed on one of the other needles. So it's not like you can just take all the discs, set them off to the side, and then put the last disc somewhere else. You had to take one disc out and then put it in another needle before you can take the next disc. The third rule is that a larger disc cannot be placed on top of a smaller disc. So if you wanted to move a disc on top of another one, you had to make sure it was a smaller disc. Now the priests were told that once they moved all the discs from the first needle to the third needle, the universe would come to an end. That's right, the universe can come to an end in any minute now, any second, as soon as the priests are done moving that 64th disc over to the third needle. We see that this is not a very simple task. Just thinking about moving 64 discs from one needle to another while making sure that all the discs are lined up properly, that's quite a daunting task. Even for something like 3 or 4 discs would be pretty difficult to do right away. So what we want to do is actually write a program that would print the sequence of moves needed to transfer all the discs from the first needle to the third needle. So we want to print a set of instructions that would tell us how to actually move all these discs while satisfying those 3 rules. So let me just show you an example of what this would look like. So here's an example with 3 discs. So we have disc 1, 2, and 3. We see that the third one is the largest disc, at least I try to draw it that way. The second disc is the second largest, and then the first disc, disc 1, is the smallest, and we have needles, which I'm calling A, B, and C here. So our task is to take these 3 discs and move them to the third needle. We can only move one at a time, and when we move one, we have to place it on one of the other needles. We could use needle B, and then the larger disc cannot be placed on a smaller disc. We can actually use recursion to solve this problem. That's why we're talking about this problem in the recursion section of the course. So let's just suppose the first needle only has 1 disc. That's it. So if there's only 1 disc, all we have to do is just move that disc directly from needle 1 to needle 3, or needle A to needle C if we used our earlier example. Now let's suppose our first needle only had 2 discs instead of 1. So what we would do here is we would move the first disc from needle 1 to needle 2. So we'll move it to the middle disc. Then what we would do is we now have needle 1 being the case of only 1 disc. So we can move that second disc from needle 1 to needle 3. And then finally we can move that 1 disc from needle 2 and move it to needle 3. And then we would have successfully moved both discs from needle 1 to needle 3. All right, so what if we have 3 discs in needle 1? Well, these first 2 discs, the top 2 discs, they need to be moved to needle 2. And once we've done that, we won't worry about how we did that in just a second, but let's just suppose we move both of those discs to needle 2 somehow. Then we can move disc 3 from needle 1 to needle 3. And then all we have to do left is just take the top 2 discs from needle 2 and move them to needle 3. So we would use the same strategy from before when we moved the 2 discs from needle 1 to needle 2. Well, how do we do that? Well, in this particular case, we could use needle 1 as the intermediate needle, whereas before, when we moved the first 2 discs from needle 1 to needle 2, we could use the third needle as the intermediate needle. But there always has to be some intermediate needle in order to transfer all these disks. In fact, let's just walk through the example of moving 3 disks from needle 1 to needle 3, or in this case, we're going to say A to the C. So here's our original problem where all 3 disks are on needle A. So the first task is to get disks 1 and 2 to be in needle B in this case. So the way we're going to do that is we're going to use C as our intermediate needle. So the first step is we're going to take disk 1 and we're going to move it to needle C. Now, this should be a little familiar because we just talked about how we handle moving 2 disks. So we're going to do the same thing, except instead of going from needle 1 to needle 3 or needle A to needle C, we're going to go from needle A to needle B. All right, so we moved the first disk to needle C. So now all we have to do is just move disk 2 to needle B. So we see here that we'd have each disk on a different needle, and that's fine for this. Now all we have to do is just finish up having the top 2 disks on needle B, so we just need to move disk 1 from needle C to needle B. So now we have both disks on needle B. Once we have that, now we have to move disk 3. So we could just move that from needle A to needle C quite simply. Now since we've moved disk 3 to needle C, we need to move disks 1 and 2 to needle C as well. So in this case, we're going to use needle A as our intermediate needle. So all we got to do is just pretty much do the same strategy as we did before. So in this case, we're going to move disk 1 from needle B to needle A, because that's the only disk that we can move. But now we see once again that we have a disk in each needle, which is perfectly fine. We can then move disk 2 from needle B to needle C. And then all that's left is just to take disk 1 from needle A and move it to needle C. And sure enough, we see that we have all 3 disks on needle C, where the smaller disk is on top of the next disk. Now we can generalize this to the case where we have 64 disks. So let's say the first needle has all 64 disks. So we need to move all of them to needle 3. Well, the strategy is we need to get disk 64 over there. But in order to do that, well, we can't do it right away. We have to move the top 63 disks first. We have to make sure that they're all on the second needle. Once we've done that, then we can actually move everything over. So the first step is to move the top 63 disks from needle 1 to needle 2. Once we've done that, we won't worry about exactly how we did that just yet. Let's just assume that we do that. Then we can move disk 64 from needle 1 to needle 3. So let's say we make that move. So now the top 63 disks are all on needle 2, and we need to move all of them from needle 2 to needle 3. So eventually we got to get disk 63 over there. Well, if we're going to make that work, if we're going to move disk 63 from needle 2 to needle 3, well, we first got to deal with the top 62 disks. So we're going to have to move all those from needle 2 to needle 1. And then once we have that done, then we can move disk 63 from needle 2 to needle 3. But we first got to have the top 62 disks over on needle 1 first. So let's say we do that. Well, then we need to move the remaining 62 disks. Well, how do we do that? We would use the same approach before, where we're going to have to move the top 61 disks over from needle 1 to needle 2, and then we can move disk 62, and we just keep repeating this until eventually all of the disks are moved over to needle 3.